Okay, it's now time to set up the design rules. The PCB editor is a rules-driven environment, meaning that as you perform actions that change the design, such as placing tracks, moving components, or auto-ratting the board, the software monitors each action and checks to see if the design still complies with the design rules. If it does not, then the error is immediately highlighted as a violation. Setting up the design rules before you start working on the board allows you to remain focused on the task of designing, confident in the knowledge that any design errors will immediately be flagged for your attention. Design rules are configured in the PCB Rules and Constraints Editor dialog. This is under the Home tab over in the Design Rules section by clicking on Design Rules. The rules fall into 6 categories, which can then be further divided into design rule types. The rules cover electrical, routing, mask, plane, manufacturing, and placement requirements. So we're going to go ahead and configure the routing width rule for our signal nets. So with your PCB as the active document, go to the Home tab, over to the Design Rules section, and open the PCB Rules and Constraints Editor dialog. Each rule category is displayed under the Design Rules folder on the left-hand side. Double-click on the Routing category to expand the category and see the related routing rules, and then we can look on width to display the currently defined width rules. If we click on the existing width rule to select it, when you click on the rule, the right-hand side of the dialog displays the settings for that rule, including the rules where the first object matches, also referred to as the rule's scope, what you want this rule to target effectively, in the top section with the rule's constraints below that. Since this rule is to target the majority of nets in the design, the signal nets, we want to confirm that the where the object matches is set to all. The settings in this rule are the defaults for a new PCB. We're going to edit the minimum, preferred, and maximum width values and set them to a flat 0.25 millimeters. And because the dialog is already set in metric as our units, we do not have to actually type in the mm. You can, but it is not required. And we can notice that the values as we set them are shown and reflected on the individual layers at the bottom of the dialog. And we could also configure the requirements on a per layer basis if we decided we wanted to change them in that way. This particular rule is now defined, so we're going to go ahead and click Apply. This will dedicate the rule. You can see it's been modified up here. This will dedicate the rule but keep the dialog open. The next step is for adding routing width for our power nets. So we're going to actually add and configure 2 new design rules to specify the routing width for the power nets. To add and configure these rules, again within the PCB Rules and Constraints Editor, with the existing width rule selected in the design rules tree on the left, we're going to right click here and we're going to select New Rule. This will add a new width constraint rule. The rule will come up with the default name of width_1. We're going to go ahead and click onto this rule so that we can configure its properties. Over here on the right in the name field, let's go ahead and change this to width 12 volt. And in the section here where the first object matches, we're going to go ahead and select net from that list. And then we want to choose the 12 volt net in the drop down as shown here. The last step is to set the constraints for the rule. So we want to change the minimum, preferred, and maximum width. The minimum we want 0.25. The preferred we want 0.5, and the max we want 0.5. Repeat this sequence of steps to define another routing width design rule that targets the ground net, and we'll go ahead and use the same constraints values rather than typing them in again. Since we already have one with those values, the easiest way to do this is to use the duplicate rule command in the right click menu. So we'll right click here, duplicate rule. We'll change this to width ground. And we want to make sure to also remember to change the net to ground. and the other values are already there. Again, go ahead and click Apply to dedicate these changes while keeping the dialog open. Next up, we're going to define the electrical clearance constraint. So we want to expand the electrical category in the tree of design rules and then expand the clearance rule type. Click to select the existing clearance constraint and note that this rule has two scope fields. That is because it is a binary rule. The rules engine checks each object targeted by the setting on where the first object matches and checks it against the objects targeted by the where the second object matches setting to confirm that they satisfy the specified constraint settings. For this design, it's suitable to define a single clearance between all objects. In the constraints region of the dialog, we're just going to set the minimum clearance to a flat 0.25 millimeters. And again, press Apply and keep the dialog open. Next up, we want to define our routing via style design rule. So we're going to go ahead and expand the design rule tree for routing, and then we want to locate the routing via style design rule. Since it is highly likely that the power nets can be routed on a single side of the board, it's not necessary to define a routing via style rule for signal nets and another routing via style rule for power nets. Edit the rule settings to the values of 1 millimeter for the diameter and a hole size of 0.6 for the minimum, maximum, preferred, and note, as you saw there, that you can press tab on the keyboard to move from one dialog to the next. And again, because we're in metric mode, the millimeters is implied, and so we don't actually have to type it in. It can just kind of be a quick way to jam through the settings there and get them set. And for here, now that we've got this all set, we're going to go ahead and click OK to close the PCB rules and constraints editor. And then we want to perform a file save all. You may have noticed that the transistor pads are showing that there is a violation. If we right click over an object that has a violation marker, we can go down to the violations submenu and look at the clearance constraint violation, and we can notice that it's between a pad on the multi-layer and another pad on the multi-layer, and that the clearance is actually 0.22 millimeters, and we've specified a 0.25 millimeter clearance. Now, we're not going to worry about this violation for now because we will actually resolve it a bit later, but this should have us set up well, and with our documents all saved, we are ready to get the PCB placed and routed, and then we can set up and generate our outputs.